Hello, everyone. My name is Hassan Harb. I am currently an assistant professor at York University in Toronto, Canada. It's been a while, it's been almost maybe a month and a half since I posted my last video. But honestly, I wanted to take a little break, a lot of work. But now, finally, I'm back. And I'm also excited to continue posting videos about mathematics and maybe later about physics. And I hope you also guys are as well as excited as I am. Actually, I wanted to post this video just to tell you about the new course I am planning to start with, which is linear algebra, or more precisely, Introduction to Linear Algebra. So that is actually the new course I'm working on, and I will start posting lectures very soon on this topic. So, Introduction to Linear Algebra. I wanted to tell you about the topics, the main topics or the main chapters. So, first of all, I will start with chapter 1, which is linear systems or Introduction to Linear Systems. What is a linear system? How to solve it? How to use the Gaussian elimination, Gauss-Jordan elimination, as well as what is meant by the raw echelon form and reduced raw echelon form, as well as homogeneous systems. So that will be chapter 1. Chapter 1 will be an introduction to linear systems. Chapter 2 will talk about matrices, or more precisely, matrix algebra. How to add, subtract matrices. First of all, what is a matrix, right? And then how to add, subtract, and multiply matrices, what is meant by the inverse of a matrix, how to use matrices to solve linear systems, as well as talking about special matrices, for example, symmetric and skew-symmetric matrices, and so on. Then, that's chapter 2. So chapter 2 is matrix algebra. Chapter 3 will talk about determinants, how to calculate the determinant of a matrix. We will start, of course, obviously, with the very simple 2 by 2 matrix, and then generalize it to larger and larger matrices. I will try my best to do as many examples as possible, from the very simple to the so much complicated. So I will do my best to cover all that. And of course, I will as well mention some special cases, some tricks, for example, which are really very useful when you talk about determinants, when you talk about calculating the determinants. There are some tricks which help us calculate the determinant very quickly. I will also cover Cramer's rule, what is meant by Cramer's rule, and of course, I will do some examples, obviously. So that's chapter 3, which is determinants. Next, I will move on to vector geometry. So what is meant by a vector, how to deal with the components of a vector, how to calculate them, how to represent, obviously, a vector in a rectangular system, and how to find equations of lines and planes, and all that. That's chapter 4. After that, I will start with a chapter which is really super important, which talks about vector spaces. So here we will start a little bit working with some abstract stuff. What is meant by a vector space? When do I call a space vector space? What are the properties of this vector space, and so on? Of course, I will cover the so-called subspaces and what is meant. Let me just first of all see the topics on vector spaces that I prepared. Yeah, so definition of a vector space, what is a subspace, what is meant by linear combinations and linear independence. Of course, it's very important to talk about the basis or a basis of vector space, how to find a basis of a vector space, and what is meant by a basis of vector space. And of course, what is meant by a spanning set of a vector space, as well as what is meant by the dimension of a vector space. That is chapter 5. Then I will move on to chapter 6, which is also super important. It talks about eigenvalues and eigenvectors. What is an eigenvalue of a matrix or an operator later? What is an eigenvector? What is meant by eigenspaces? how to find the so-called characteristic polynomial, and how to diagonalize a matrix if possible. So this is going to be chapter 6. Next, it'll be linear transformations. Again, what is meant by linear transformation? What are the properties of a linear transformation? When do we call a linear transformation linear operator? As well as composition and inverse transformations. I will also talk about isomorphisms, how to represent a linear transformation by a matrix, and finally, what is meant by the change of basis of a linear transformation. So that is going to be the chapter which is linear transformations. The final chapter in this course I am planning to cover is related to matrix factorizations. How to factor a matrix, or in other words, how to write it as a product of other simpler matrices. What is meant by simpler matrices? You will see later, I mean simpler in terms of computation. So this is really very important. It's super important to study how to factor a matrix because, as you will see later, and as I just mentioned, it really helps us speed up our computations a lot. I will discuss some very important matrix factorizations or decompositions. Let me mention a couple of them. I will mention the simple LU decomposition, as well as the QR decomposition, spectral decomposition, and the other decomposition, which is super important, which is called the singular value decomposition, or SVD in short. Of course, I will talk about them in details, and I will tell you what are some applications of these factorizations or of these decompositions. Okay, so 8 chapters. Let me just list them once again. So linear systems, matrix algebra, determinants, vector geometry, vector spaces, eigenvalues and eigenvectors and eigenspaces, all that, linear transformations, and finally matrix factorization. So that is the syllabus of the course I am planning to start posting lectures on. I hope you like the idea, and I kindly ask you, if you do like the idea, to just hit the like button, and I would like to hear your comments if you would suggest, for example, some other topics that I missed, or any other suggestions. Any other suggestion is really welcomed. So I would like to hear from you, and see you soon when I start posting lectures on linear algebra. And that's it for now. See you later.